Thank you. Thank you so much for that introduction. Hello, everyone, and hope you're doing great and have been enjoying the overall Climathon sessions. Myself, as being introduced, I'm Mohib Khan, and I've been working with AWS for almost 2 years and 9 months to be precise, and mainly working with ICT industry, helping customers by understanding their business challenges and trying to transform them or address those problems, business problems, through AWS technology, AWS solutions, AWS services. And previously, I guess yesterday, you guys actually took a session on a brief session on sustainability in the cloud, in specific to AWS, how the architecture looks like, what are the frameworks. Today, I will be taking or resuming that session into a bit zoomed in version into the best practices for sustainability in the cloud. If you have any questions through the course of this session, please feel free to type into the chat and I'll try to address them at the end of my session. So when we say best practices in the cloud, the first thing that comes into the mind is energy. And when we say energy, what kind of energy are we talking here about? So we have Peter DeSantis, who is actually an AWS Senior VP for computing utility. And back in 2 years, he said that the greenest energy is the energy that we don't use. So what he means by that, or what we can interpret from that, is that the more efficiently you can design your applications or you can run your workloads on the cloud, the less energy you will need to consume that, the less energy you will need to run that workload, whether it's your compute, whether it's your storage layer. So how exactly you're going to design your workloads to consume efficiently energy. So that was something we wanted to understand. What are the impacts of the services that you're going to use on top of AWS or in cloud, and try to quantify them through the entire workload lifecycle, and to take actions by applying the best practices to impact of your to reduce the impact of your workloads. So in general, sustainability is a very, like, to address what is sustainability. Sustainability is a very broad field, right? So it will not just cover the technology part, it also covers the social part, it covers the economical part, the environmental aspects. So what we are going to focus today is mainly focusing on the environmental aspects, especially energy consumption and its efficiency, as this is an important lever that architects in improving and reducing the resources that you use on AWS. By resources, what I mean is the AWS services that you're going to use. So for example, if you're just going to use a basic virtual machines, so how are we going to use them? What kind of compute resources are we going to use in order to optimize our energy consumption? So this picture would seem very much familiar to you, probably as this was discussed in yesterday's session as well. So this is a shared responsibility model for sustainability. So how AWS is helping our customers to be able to design our workloads that are energy efficient and being sustainable. So AWS designs the buildings, the official, the data centers, the facilities, and the rooms, the telco rooms, and the servers that we have, and the construction of overall buildings. We take care of those from infrastructure perspective that are actually, from recycling. AWS purchases the energy and ensure that the energy and other resources such as water is needed for cooling the HVAC systems are used efficiently. And lastly, the AWS service teams run managed services and optimize them for sustainability. That being said, customers are actually responsible for making architectural decisions when it comes to the architecture of the actual workload, actual design, how you can make that more energy efficient and more sustainable. It's the design of your data and how you use that. It's actually going to be how you do the code efficiency, because the more efficient code you write, the more efficient resources you will consume on top of AWS. So let's go into the deeper part of the design principles in general. So when we say the design principle, the first thing is that understanding your impact. This means that measuring the environmental impact of your application or your cloud workload. So for example, if I'm going to host an application on AWS cloud, what is going to be the customer use? What would be the retirement age of this application? How I'm going to eventually decommission the application resources, or compare the productive output with the total impact of your cloud workloads by reviewing the resources and emissions required per unit of work. So you would have discussed the metrics part in the last session. This is what I'm referring to. However, just to recall that, so by metric measurements, what we're trying to say is that how much productive results you're getting from your application versus the resources that you're consuming on the cloud, in simple words. So then you try to understand this data to establish your KPIs, your key performance indicators, and evaluate the ways and work backwards, like how you can evaluate the ways to improve productivity while reducing the impact. Second part that comes into the design principles is establishing your organizational level sustainability goals. So it's not really limiting you to a specific workload, but from business perspective, from business goals objective, organization level sustainability goals. For each cloud workload that you're going to work on, you need to establish a long-term sustainability goal, such as reducing the compute and storage resources per transaction. So for example, if you have any banking application and you're trying to send a query to the backend databases, is it needed to have all day long databases? In that situation, maybe yes, because it's in banking application. Whereas if there's any other application that does not work 24 hours, for those applications, do we need to keep the resources up and running, or do we need to commit an over SLA, the service level agreement? So those are the ways where we need to optimize the resources for both compute and storage. So that's the idea of sustainability goals, which you have to establish organizational wise. This is not the technical part at the moment. This is more about the business process perspective. The third design principle that comes is the maximize your utilization. So right sizing of the workloads is the beauty that you can actually do on the cloud. Because when it comes to on-premises, most of the time, either you are over calculating or under calculating, means overutilization or underutilized. Mostly it's underutilized. So when it comes to the cloud, AWS cloud, right size workloads help you implementing the efficient design to ensure that you have high utilization of the resources that you have brought in and maximize the energy efficiency of the underlying hardware. So for example, you have two underlying hosts running at 30% utilization each. Would be less efficient if you have one host running at 60% utilization due to the baseline power consumption per host. So if you have two hosts, whether I'm talking about just in general about AWS hosts, which are again AWS Nitro based. AWS Nitro is the hypervisor that we use. So if you have two hosts running at 30% utilization, these would be consuming a lot of power, or more power, I would say, as compared to one host running at 60% utilization. Why? Because the baseline of the power consumption per host is less compared to two. Let's move on to the other one is anticipation and adopt new, more efficient hardware and software offerings. So yesterday you would have heard about a word called Graviton and Graviton 2 and Graviton 3. So what kind of compute powers or compute services you can use in order to have those better and optimized resources of AWS cloud. So the idea here is that you need to support the upstream improvements your partners or your suppliers make to help you reduce the impact of your cloud workloads. How? By continually monitoring and evaluating new, more efficient hardware and software offerings. That's where AWS comes into the picture. So our pace of innovation has been so fast that just in 2018 and 2019, respectively, that I'm going to talk about, we had close to 2,000 services and features released. So when you're working with AWS Cloud, you get constant upgrades. So previously we had Graviton 2, and at the last reInvent, we announced Graviton 3. So when you are opting for better and optimized compute powers, similarly, when it comes to storage layer, if you're moving from GP2 to GP3, that can give you better IOPS performance and lower cost, and at the same time, more optimized underlying power consumption. That's going to actually reduce the energy consumption and the carbon footprint eventually. And the other part that comes into the design principle is actually the fifth part is the using managed services. So why do we say, or how does it really reduces the uh, the efficiency of the resources and reducing the carbon footprint? I will address this as the managed services part. What is the benefits and how do we do that? But at the moment, I will leave this as a question to the whole audience. And I would love to see some responses in the chat that what do you think and how do you think using AWS managed services can help you and your customers to be designing the sustainable workloads? If I am not getting any answers, probably I'll address that at the end, that why managed services. Moving to the last part, which is reduce the downstream impact. So first we talked about the upstream impact by choosing the right suppliers of the compute services. And for example, moving to Graviton 2 or Graviton 3 from compute perspective, and storage to EBS, we call it elastic block storage. From GP2 to GP3, these are types of storages that we have available. There are more, but these are the more appropriate one for your general workloads on the cloud. Talking about the downstream impact, it's more about talking about reducing the amount of energy or resources required to use your services. So when we say that, it means that how the end user, the customer, how we are going to reduce or eliminate the need for customers to upgrade their end devices. So how, like, do they need some high-end devices to actually use your services? So we recommend that, test using device farms. We have AWS device farms as well. There are a lot of services for mobile apps that you can test with as well if you're building any mobile application to understand the expected impact, and test it with your customers to understand the actual impact from using your services that you have developed. So it's an end-to-end cycle, all the way from understanding your impact, your business goals, utilizing your resources maximum, as we talked about, two hosts versus one host, new efficient hardware, which is your upstream part, running your applications. And the last part was your downstream impact, which is to your end user, whether it's your citizens, your another organization. So that's the idea. We have, on purpose, we have left the managed services part just to get the audience feedback, because this was partially covered in my colleague Tariq's session yesterday. I just want to get the answers. What was your understanding of managed services usage and consumption, and how does it help to build sustainable workloads? Now, this is where we are going to talk about best practices to design sustainable workloads on cloud. So when building sustainable workloads in AWS, what we really should be thinking about is how we can optimize the workload placement and optimize your architecture of your application for your users, your software, the application that you're going to use, how you're going to place your data and its consumption, what kind of hardware, and how you're going to do the development of your application, the testing of your application, the deployment patterns, and in order to increase your energy efficiency. So let's look into the best practice areas. I'll just highlight them from overview, and then we will zoom into each. The first one that comes into the picture is the region selection. When we say region selection, it's basically AWS region. And what is an AWS region? So AWS region is a distinct geographical location which has clusters of availability zones. An availability zone has one or more discrete data center. So this is the idea. So each availability zone would have, so if, for example, if you are in Egypt, right? And we're talking about having a region, for example. So within Egypt, you should have at least 3 availability zones. And each availability zone would have one or more data center. And that's how a group of data centers make an availability zone. And 3 availability zones minimum would make one AWS region. So what kind of region that you're going to use? That's first. Second thing is your user behavior patterns. We will dive deep into all of these shortly. The third one is your software design and your architecture patterns, your user behaviors and your architecture patterns. How you move your data and how you store your data. How do you retain your data? For example, if you have long-term retention for your data, are you going to keep it on the hot tiers of the storage, or you have something to move them to the cold ones? And of course, the hardware patterns, as we have touched base upon this about moving into the more optimized compute resources. And last and not the least is how you deploy and develop your application itself. So each of these areas represents opportunities for what? To employ best practices to reduce the sustainability impact of your cloud workloads and maximize utilization of your workload and efficiently on being efficient on energy and actually minimizing the waste. So I'm not talking about the general waste. We are here talking about the waste of compute resources that are not used, and unnecessarily it reduces that and the carbon footprint because to generate that energy. And in order to support that or to power that workload that you have designed. So let's start zooming into each one of them. Let's start with the first best practice, which is the region selection. So today we have fully fledged 27 regions, including the UAE region, which has been recently announced just actually yesterday. So the idea here is to choose the nearest region that has renewable energy resources or Amazon renewable energy projects, and regions where the grid has a published carbon intensity that is lower than other locations. So you can go ahead to AWS console and you can actually see from the console that which region, AWS region, has the lowest intensity of the carbon. And that's the preferred idea to do that. However, if you have a certain workload that requires compliances with data residency and data sovereignty, not allowing you to go outside of the country, That's a different subject overall. And then we have different approaches like hybrid solutions or working with test dev environments in the cloud and production in country. So there are different methods to do that. But in general, the idea is that, we are still growing as an AWS. We are growing in different regions, and we are not done yet with growing our regions. So hopefully we will be in many other major countries. So it is important to choose a region for your workload where the carbon intensity of the grid, AWS grid, is lower and located near Amazon renewable energy projects. So these renewable energy projects can be seen at the link of the Amazon sustainability website. And we as an Amazon in global is on a path to power all of its operations with renewable energy sources by 2025. So we just have 3 years to fulfill that promise that we are on, is to actually power all of our operations, whether it's cloud or whether it's retail, to be on renewable energy resources. So currently, as we speak, AWS purchases and retires environmental attributes like renewable energy resources credits, renewable energy credits, and guarantees of origin to cover the non-renewable energy we use in the regions, mainly in US and European regions at the moment. If you're interested, I can also share the links with you for the renewable energy projects that Amazon has been working on. So first thing was I have 27 regions on AWS. I need to understand which region has the lowest carbon intensity um, near the AWS regions grid. I choose that region. Second best practice is to introduce your users' behavioral patterns. What do we mean by that? User behavior patterns means is to understand how you can align your workload better to your customers' need and meet your sustainability goals. So you will meet your customer needs while meeting your sustainability goals. How? We need to look at when, where, and how your users, or I mean your customers or your users, use your application or your workload, especially what they don't use. So you need to understand what kind of things are unused. So this is what refers to the initial quote that I used from my colleague, is that the greatest energy is the one that is unused. So we need to understand what part of the resources or the services are unused so that we can remove them and revisit the service levels promised to your internal or external users. So we need to understand, are we really overcommitting and over delivering on a service level agreement? And does this over delivery of an SLA cause you to run excess resources? So how you can do that? You can design your workload in such a way that it should auto scale with the load and allowing you to meet your service level agreements. Eliminate the creation and maintenance of unused assets, so continuous monitoring of those assets. And that's the beauty of elasticity in the cloud. Optimize the geographic placement of your workloads. How? By choosing the region which are closest to your consumers, your users. So for example, if I'm going to build an application, which is a global application, right? And let's say I'm developing a fitness or healthcare application that just monitors my heartbeat and my calorie intakes. So if I'm going to do that and I'm seeing that my most users are coming from Egypt or Middle East or coming from US or Europe, so I will start to choose the regions accordingly, and I will decouple my assets and optimize the placement of my workload according to my user's location. So that is also a way to understand your user behavior patterns and optimizing your workloads by not putting everything in one place and increasing the energy utilization. And at the same time, it comes to your team member resources because you need the activities to be performed, and you optimize the team member resources. The third thing, which we are going to look at now, is how you do your architectural patterns and how you work on your application. So yesterday you would have looked into the asynchronous architecture where you have queues to work with, and when you have a query or task in the queue, that's where you can actually spin up the code or spin up the machines required. Sorry, I was just looking into the chat. Right. So optimizing the software architecture for asynchronous and scheduled jobs. So the idea is to put the jobs into the queue so that you can actually work less and at the same time store less and do work more efficiently. And as we said, that to understand what are the components or the services that are unused, so we can remove or refactor those workload components that are, unused. Third thing is to actually focus on optimizing the areas of your code that consume the most of the time of your resources. This was the thing that we were talking about, optimizing your team members' resources. How to actually identify which code or which area of the code requires a lot of efforts and energy and resources, because that is continuously requiring the compute power. So how we can optimize that? Is there a way we can have a strategy of testing of your code or your application? Do we have any machine learning tools that we can engage with to understand the issues or errors in the code, and how we can take off those optimizations in the code? Fourth thing is actually optimizing the impact on customer devices, as we talked about the downstream impact. And the last thing is using your software patterns and architectures that actually best support your data access and storage patterns. I will be actually addressing that in the compute and the storage part. So in a nutshell, if I just do an abstract of all of these software and architecture patterns, the idea is that you need to work less and store less. And by working less, we mean is to do work more efficiently, drive up your utilization, and remove idling resources, and use sustainable scheduling strategies. So you can schedule the jobs. For example, if your application has some peak times from morning 8 till 5 in the evening, you schedule those peaks to take care of it, or you design your application in a serverless architecture where you can have the jobs based on the uh, queries or the API calls received, or you can just schedule your jobs at night if you have, for example, so image processing happening at night for researchers, or with genome data, or with let's say you're working with seismic imaging or fluid dynamics, talking about high performance computing, and you need to utilize those resources. How you can put them into a batch instead of running those interactive jobs, put them into batch, and how you can process them at night to optimize the resources. And at the same time, how we can reduce the consumption of your GPUs. So we can go into a lot of details when we talk about a specific use cases. Let's talk about the third practice. So we talked about, fourth practice. First one was region selection. Second one was user behavior patterns. Third was the software and architecture patterns. Fourth one now is the data patterns. So when we say data patterns, so data lifecycle management is a big takeaway here actually. How are you storing your data? Which storage tier you're storing it? Why? Because storing it in a colder access tiers means the underlying hardware providing the hotter storage tiers can be less. So for example, if I'm going to have a lot of images or PDF files or just some CSV files, why am I going to use block storage for that? So I don't need those hot storage tiers. I can just put them into a colder storage, which can be a way of putting into object storage. And even in object storage, how long do I need to keep this in a standard tier? Because in Amazon Object Storage, which we call Simple Storage Service, S3, there are multiple tiers to use. So choosing the right storage tier can help by moving it to a long time archiving. For example, if you have a data retention requirement for 10 years, for 5 years, you create the data life cycle, which is again a feature in S3, in order to move it from hot tier to cold tiers.
Mr. Mohib, we can't hear your voice.
Can you hear me now?
Yes, we can hear you now. But you cut off for a few seconds.
Hello,
Hello, we can hear you now.
am I audible now?
Yes. Can you hear me?
Can you please type in the chat? I'm not able to hear you. Okay, great. Thanks.
All right.
So the idea here is that you also need to use shared file systems. For example, if you're working with Windows, we have the FSX file systems for Windows. And if you're working with Linux file systems and you're looking for shared file storages, we have the EFS for that, Elastic File Systems for that, Elastic File Share. And when it comes to object storage, to access your common data, for example, you're trying to build your data lakes, for example, or you're working with the healthcare data and you want to make a health lake, you can actually start building on top of the object storage access on S3. So the idea here is how you can move away from objects to also from block storage that actually consumes a lot of underlying power. Why? Because it's a hot storage tier. So that's another way of understanding your data patterns. And when it comes to data movement across networks, because now how much movement there is between one tier to another, or between your one application to another application, or from one data store to another data store. So how we can minimize that data movement across networks, because you will need that network connectivity between those resources that would actually require again the energy consumption. So how we can minimize that? So we need to understand these while designing your application. And how much backup data do you need? Because a lot of core or mission critical applications, you're taking your snapshots, you're trying to understand how to take backups. So only backup the data when it would be more impactful. Or is it impossible to recreate? So back up those data, because at times, yes, even in I have seen in my past experience that even for development environments, people are taking backups hourly. Despite that the changes are not happening hourly, it happens 8 or 9 hours per day, but the backups happen continuous for hour. So probably a strategy for the backup needs to be optimized, because you will be putting those backups again
to S3. And even moving to S3, what happens is that the development timeline, you started the backup from month one and you now have reached to month 4 of your development, and you're still keeping the backup of week 1. So they are unused. Your development has made changes to a long way. Do you still need the backup for week 1? So depending on the requirement and the strategy, we need to optimize that and be alignment. This is where the alignment comes from your organizational sustainability goals. The fifth one was that we talked about was the hardware patterns. So, which type of compute or hardware resources that you're going to use in order to optimize your energy efficiency? So, using the capabilities of AWS Cloud, you can make more frequent changes, and this is the beauty of cloud, that you are flexible, you have elasticity, you can fail fast, so and you can experiment things. So when we talk about experiments, what you can actually do is you can actually change your workload implementations to different hardware resources, different types of computes available. Today on AWS, we have more than 470 plus virtual machine types. So just and you can try to move away from, for example, if you're working with x86 workloads, how you can opt for ARM-based instances, or you can opt for AMD-based instances, or move to ARM-based Graviton instances. So use the minimum amount of hardware to meet your needs, and how you can configure the auto-scaling features capabilities on the cloud, and use the instance types. As I mentioned, we have more than 470 plus instance types. Use the one that meets your requirements with the least impact. And then the other thing that comes is that general recommendation is that not only the right ratio of between compute to memory, it also depends, do you really need GPUs, for example? So if you're working with, let's say, computer vision, I'm not sure if we have the machine learning audience here as well, but if, for example, if you're working with machine learning and some image processing and video processing, maybe for the training data sets, you might be working with, yes, you need GPUs, but do you need only GPUs? Or can I mix match both GPUs and CPUs? So that mix and match can optimize your compute resources and eventually reducing your carbon footprint. So this is the idea how you can optimize your resources of GPUs. And when it comes to inferencing of those use cases or those machine learning pipelines, do I need GPUs in inferencing? So that's where you can add again, because what happens is you have the video coming in. For example, you have a video coming to your data source, a streaming video. You can take up pictures and frames of each frame. So you take 10 screenshots or one screenshot per frame, and then you can convert it into base 64 and then goes into analyzation. And for inferencing, maybe I can just use my CPU instead of, because training of the model is done on GPUs and CPUs, but inferencing, maybe I can just use CPUs. So you can understand the way how to use the optimized hardware. And how you can do that, you have a service called AWS Compute Optimizer. You can also use AWS Compute Optimizer that can help you understand how you're using your resources and how you can fine tune them. So moving on, before I move on to another one, another example is the Graviton, which I have mentioned earlier. It's the ARM-based ARM-based AWS design chip. So this is something what we have worked with Graviton. So Graviton 2 was actually launched in 2019, and Graviton 3 was launched last year. And it has been the most power efficient processor AWS offers today. In AWS, it is easy to test a new chip. So for example, if you're already working with the EC2s today, x86, you can do an experiment, not on your production workloads, of course, but you can actually try to replicate them and then try to see if you can move them from your current x86 EC2s to either to a serverless or moving towards microservices architecture, such as trying to use containers or Kubernetes, or how you can move to from as is from x86 to Graviton 3. The last feature that we are going to talk about as a best practice for sustainability in the cloud is development and deployment process. So this is a very crucial one for me actually, because this is where everything starts. Look at your whole software life cycle, your whole application life cycle to support the improvements for resource efficiency. How? Because when you're trying to, build your application and you're writing your code, your source code, and your developers are, putting all of their efforts into building the right application to meet your criteria needs, how much optimization we can do, not just on the team resources, but at the same time, if I use the CI/CD managed CI/CD services, the continuous integration and continuous deployment services like AWS Code Builders, to avoid long running inefficient build. So if you're trying to do some testing scenarios and you're constantly deploying A and B servers, so is it requiring unnecessary load? What if I use managed services to do that? It can help me go through my code, debug them, and at the same time do the A/B testing or blue-green testing on my code on my behalf based on the criteria I set. And at the same time, it will help me to keep my workload up to date. So these are the testing methods that you can use, and these are the way of potentially improving the sustainability of your workload. Third thing is that increasing the utilization of your build environments. This is what I was referring to. If you're just having multiple environments to do the testing of your A/B testing or your blue green testing or canary testing, whatever your testing uh, methodology is, how you can increase the utilization of your environments. Uh, Optimizing your software build and deployment process. It should also help you make it safer and easier to introduce and validate improvements in your own software and the third-party libraries that you're going to use. So, for example, how performant are the laptops used by the developers or the data scientists in machine learning use cases? Could these development workflows use cloud infrastructure like remote IDEs, or the studios like Amazon SageMaker Studio, or the development environments like AWS Cloud9? So can they use that instead of using those personal machines or the laptops for the developers and data scientists? Can they use other tools like workspaces that we have in AWS, like a virtual desktop? So how we can still optimize the performance and reduce the energy. So overall, these were the key points that I wanted to touch upon when it comes to best practices for sustainability in the cloud. So if I just have to recap them, I will just bring it back on the screen. That what are the sustainability best practices? So again, which AWS region you're going to choose according to your user needs? What are the user behavior patterns? What time do they come, or what are their needs, and what type of services that they use? Software and architecture patterns. How are you going to design your application, and how are you going to do the application designing? For example, are you continuously going to go with monolithic architectures? Are you going to use optimization of the code? Then it comes to data patterns. Are you going to keep everything in the hot storage tier, or you can actually change the storage tiers and do the retention accordingly and have the data lifecycle management? Next, of course, the hardware patterns. What kind of compute optimization you can do in your AWS workloads? And last and not the least, how the development works. Are there tools that you can allow your data scientists or your developers to use on cloud or virtual desktops, or how you're going to do your testing strategies and methodologies, and in order to do a better deployment process. And with that being said, I will also like to bring it to the conclusion, and just my screen is going here and there, actually everywhere. So these are the other resources that I will be also sharing in the chat with you all, as the well-architected framework that we have. What is the sustainability pillar of well-architected framework? And if you have any questions and you should like to understand more about the best practices, or would you like to train on the labs, these are the links and the resources that you can visit to. And I am more open for the questions. But before I move on to the questions, I'd like you to answer my question about the managed services part. So why we use AWS managed services, and how it can help to optimize the resources. So I'm waiting in the chat for the answers. Lana, you asked a question: is there a need for a small margin of extra workload such that the users don't run out? So I think you're talking about having an extra buffer in your compute capacity. And the answer is that you can use the auto scaling features, whether it's a scheduled base or whether it is based on the CPU utilization of your machine. So for example, if you have two machines in a cluster, and as soon as they reach into, let's say, 70% of the CPU utilization, it will add another machine based on the configuration of the auto scaling group, so that you never run out of capacity. So I don't see the answers of managed services. So probably I'll try to help you recall why we can use the managed services in order to get optimization in your energy consumption. So sharing services across the board for a cloud service provider maximizes the resource utilization. So AWS as a cloud service provider, when we are giving the sharing services to our broad customer base, it helps us to maximize the resource utilization. Eventually what happens is it reduces not just the cost for the end user, for the customers, it also reduces the amount of infrastructure needed to support the cloud workloads. And at the same time, when you are using the managed services, it can help minimize your impact. How? Such as automatically moving infrequent access data to cold storage with Amazon S3 lifecycle configurations, or EC2 auto scaling that we just talked about. That if you have two machines and if you are having 60-70% utilization, add one more machine. And once it comes back to that 50-30% utilization, it will remove that machine. It will be no longer in that auto scaling group. So you can, that's the beauty and that's the pure elasticity that you're looking for. And when it comes to reduce the carbon footprint at the same time, you can actually also use your databases that are running on virtual machines. You can move them to the managed database services that again comes across sharing services that reduces the underlying hardware utilization. So I think we are on time. Betija?
Yes, if there's no more questions, then yes, that's it for your session. And if anyone asks any questions later, we will share them with you. You can answer them and then we will share it back with them.
For some reason, I'm not able to hear you, but I think it's an issue from my side.
Can anyone else hear me?
Yes, Hatice, we can hear you.
Okay, so I guess it's an issue from your side, Mr. Mohib. I'll just write in the chat for you.